Okay, so once again, good day. So designing correct routines for controlling concurrent activities proved to be one of the most difficult aspects of system programming. So the ad hoc techniques used by programmers of early multi-programming and real-time systems were always vulnerable to subtle programming errors, whose effects could be observed only when certain relatively rare sequences of action occurred. So the errors are particularly difficult to locate since the precise condition under which they appear are very hard to reproduce. So in this topic, you should be able to discuss basic concepts related to concurrency, such as race conditions, OS concerns, and mutual exclusion requirements. Understand hardware approaches to support mutual exclusion. Define and explain semaphores, monitors, and explain the reader's writer problem. So fundamental to all of these areas and fundamental to OS design is concurrency. So concurrency encompasses a host of design issues, including communication among processes, sharing of the competing for resources such as memory files and I/O access, synchronizations of the activities of multiple processes, and allocation of process short time to processes. We shall see that these issues arise not in one multiprocessing and distributed processing environment, but even in single processor multiprogramming systems. So to give us more details about the topic, let us all welcome our presenter. Go ahead.
Thank you, Pastor. So, our topic for today is concurrency, mutual exclusion, and synchronization. So, first off, before we proceed, what would be the possible meaning of a concurrency? So, in English language, concurrency is the fact or two or more events or circumstances happening or existing at the same time. So, there are two more instances that is happening at the same time is the basic idea of concurrency. So, all right. So in operating system, concurrency is the execution of multiple instruction sequences at the same time. It happens in the operating system when there are several processes threads running in parallel. The running processes threads always communicate with each other through shared memory or message passing. Concurrency results in sharing of resources, results in problems like deadlocks and resources starvation. All right. So on the next slide, concurrency, it helps in techniques like coordinating execution of processes, memory allocation, and execution scheduling of maximizing throughput, as what had Mr. Marmelo mentioned earlier. The next one is what would be the principles of concurrency? Both interleaved and overlap processes can be viewed as example of concurrent processes. They both present at the same time. So what the relative speed of execution cannot be predicted. It depends on the following. The first principle is the activities of the other processes. So concurrency or the concurrent processes are still depends on the activities of the other processes or the other softwares that is running at the same time in parallel thread. The second one is the way operating system handles interrupts. And the last one is the scheduling policies of the operating system. All right. So on the next one is what is the problems in concurrency that we may possible encounter? The first one is sharing global resources. Sharing of global resources safely is difficult if two processes both make use of a global variable and both perform read and write on that variable. Then the order in which various read and write are executed in critical. For the second one is optimal allocation of resources. It is difficult for the operating system to manage the allocation of resources optimally because the large amount of commands, different threads, different commands, different processes running in parallel. The next one is locating programming errors. It is very difficult to locate programming error because reports are usually not reproducible. The last one is locking the channel. It may be insufficient for the operating system to simply lock a channel and prevents its use by other processes. For the next one is what would be the possible advantages of concurrency? Running of multiple applications. It enables run multiple applications at the same time. It enables to run multiple applications concurrently. The next one is better resource utilization. It enables that the resources that are unused by one application can be used by other application, which means that if ever one application or one process doesn't use a resource, the other application can still use it. It can still utilize the data that is commanded or provided by the other application. The next one is better average response time. Without concurrency, each application has to be run to completion before the next one can be run. So it is a very difficult experience of yours if ever that you will go into run both both processes at the same time, but only one of it can run onto your operating system. The next one is better performance. It enables better performance by the operating system. When one application uses only processor and other application uses only the disk drive at the time to run both applications. So it provided better performances onto your operating system because a application can only use or a different application can only can use a pure processor and your disk drive at the same time to utilize the performance of your operating system. So, what would be the drawbacks of the concurrency? It is required to protect multiple applications from one another, to prevent interrupts, to prevent lagging. Concurrency is required to protect multiple applications at the same time at the parallel thread. The next one is it is required to coordinate multiple applications through additional mechanisms. The third one is additional performance overheads and complexities in operating system are required for switching among applications. And the last one is sometimes running too many applications concurrently leads to severely degraded performance because not all of the operating system can handle so many commands or so many applications that is running at the same time. It is still depends on what kind of operating system you have onto your computer, or it still depends on um, what is the level of operating system that you had onto your computer. So um, for the next one, issues of concurrency. So the first one is non-atomic. So non-atomic operations that are non-atomic but interruptible by multiple processes can cause problems. So the operations that are non-atomic but interruptible, it can still cause an interruption onto your process or into your operating system. The second one is race conditions. Race condition occurs of the outcome depends on which of several processes gets to a point first. So, in fact, a race condition is a hazard. It is a condition of an electronic software or other systems where the system substantive behavior is depends on the sequence or timing of other uncontrollable events. It still becomes a bug when one or more of possible behaviors is undesirable. So for the third one is blocking. Blocking processes can block waiting for the resources. A process could be blocked for long period of time, waiting for input from a terminal. If the process is required to periodically update some data, this would be very undesirable. So the next one is starvation. It occurs when a process does not obtain service to progress. And the last one is deadlock. It occurs when two processes are blocked and hence neither can be processed to execute. So here are the terms that we needed to understand, or which is related to concurrency. The first one is critical section. Critical section or um, critical section of code with a process that requires access to shared resources, which may not be executed while other process is corresponding in a section code. So in critical section, it simply means that a one application cannot be run at the same time, or two applications will not be run at the same time. Only one application. That is on critical section. So the second one is deadlock, a situation in which two or more processes are unable to proceed because each is waiting for one of the others to do something. Probably a deadlock, simply a deadlock is like a lagging because your operating system cannot handle too much application that is running on parallel threads. So the next one is live lock, the situation in which two or more processes continuously change their state in response to change in other process or processes without doing any useful work. The next one is mutual exclusion. The requirement that when one is in a critical section that accesses shared resources, no other applications may be critical. Maybe in critical section that accesses any of those shared resources. So trace condition, as what we had mentioned earlier, it is a hazard or a bug, a situation in which multiple threads or processes read and write a shared data, and final result depends on relative timing of their execution. And the last one is starvation, a situation in which a runnable process is overlocked or overlooked indefinitely by the scheduler. Although it is possible to proceed, it has never been chosen. So what would be the concerns on the operating system, regardless on concurrency? The first one is keeping track of various processes. So the first concern that we needed to put in mind in our operating system relates to the concurrency is we need also always to keep in track of various processes because there are too many commands or there are some commands or some processes that is um, not needed or not that very necessity um, in our process or in our operating system. The next one is allocate and deallocate resources. We must learn how to allocate and deallocate resources, although it is very hard to allocate and deallocate resources in our operating system relating to the concurrency because of various data that is shared on our system. But the first one is we must consider first the processor time, the memory on our operating system, the files or the data that we are sharing, and the last one is the input and output devices. The next one is protect data and resources. And the last one is output of process must be independent of the speed of execution of other concurrent process. So the competition among processes for resources. Going on the mutual exclusion, it is a property of concurrency control, which is instituted for the purpose of preventing race conditions. We all know that race conditions is a bug of or hazard that can happen in concurrent process. It is the requirement that one thread of execution never enters a critical section, while a concurrent thread of execution is already accessing critical section, which refers to an interval of time during which a thread of execution accesses a shared resource, such as shared data objects, shared resources, or shared memory. The next one is critical sections, which we already discussed lately. Only one program at a time is allowed in a critical section or to run onto your operating system. Example, only one process at a time is allowed to send command to a printer. So that is the perfect example of a critical section that you can only send one command onto your printer. It is to print. The next one is deadlock. It is a state in which member of a group waits for another member, including itself, to take action such as sending message or more commonly releasing a lock. And lastly, starvation, as what we had mentioned earlier, it is a problem that occurs when highly priority process keeps executing and low priority process gets blocked for indefinite time. So the process of synchronization is a way to coordinate processes that use shared data. It it occurs in an operating system among cooperating processes. Cooperating processes are processes that are shared resources. While executing many concurrent process of synchronization helps to maintain shared data consistency and cooperating process execution. Process have to be scheduled to ensure that concurrent process to be shared data because not create data does not create inconsistencies. Data inconsistency can result in what is called a race condition. A race condition occurs when two or more operations are executed at the same time, not scheduled in proper sequence or not exceeded in critical section correctly. So the simplest example of process of synchronization is um, syncing or synchronizing your data in your Google. I think it's on Gmail. You can access different shared data on your Gmail. You can synchronize your Facebook by you can synchronize your Facebook in your Gmail. You can synchronize your Twitter in your Gmail address. You can also synchronize different applications using your Gmail address. That is why um, it called a process of synchronization because you're synchronizing different data. You're synchronizing different applications uh, that has the different shared data on it. To avoid the risk conditions, sure, to avoid any hazards, to avoid any bugs. Also, um, to exceeded the critical section correctly of the different shared data that you had or private data that you had onto your operating system. So that's all on our report, sir. Here are the references that we use regarding on this presentation.
Okay, so thank you very much. Again, the central themes now of the operating system design are all concerned with the management of process and threads, no? The multi-programming, multi-processing, distributed processing, multiple application, structured application, and operating system structure. So, as what our presenter mentioned, no, that the introduction to the concept of concurrency and the implications of the execution of multiple concurrent processes. So, we find that a basic requirement for support concurrent process is ability to enforce mutual exclusion. That is the ability to exclude all other processes from course of action while one process is granted that ability. So we heard no, also that some hardware mechanisms that could support mutual exclusion. Okay, so I think that's it.